Hello everyone. In this session we'll discuss about velocity triangle. This is the concept one has to understand carefully. We'll go to the next slide here. Velocity triangle is an important concept one should know in analyzing hydraulic machines. Hydraulic machines are turbines and pumps. So there are two types of velocity triangles, one at the inlet and the other at the outlet, as shown here, one at the inlet, one at the outlet. Now to identify both, an easy way of doing it is the quantities related to inlet velocity triangle shall have a suffix 1, and the quantities related to outlet velocity triangle shall have suffix 2. So in slide number 3 here, you can see here there is a vane and the jet is entering here. That's why this is inlet area. So this is called inlet velocity triangle. The jet is going out. The red line shows there is a jet which is going out, and that triangle will be identified as outlet velocity triangle. Now triangle is made up of three things, and what you should observe in inlet and outlet velocity triangle, the common thing, the same triangle has been shown here in a more detailed manner. The outlet velocity triangle is also shown here so that one can understand it clearly. Now the common thing that one can observe here is the velocity of the vane, which is represented by U, is horizontal here. Here also it is horizontal. That is the common thing which one has to remember for easy understanding. So in both the triangles we have got one horizontal side. The horizontal side is U, which is representing the vane velocity. So vane velocity is represented by U. And here I have listed some angles. Alpha, at the inlet, the angle made by the jet with respect to the direction of motion of vane. So if we come here, the direction of motion of vane is this. So the jet is going that way, the angle made there is alpha. So this is the common notation we'll be using, and most of the big books also utilize that. So angle made by z with respect to the direction of motion is alpha at the inlet. The same way here at the outlet also, the direction of motion of vane is this way, horizontal. This is the z, the velocity of the jet is v2. So the angle between the velocity of the jet and the direction of motion is represented by beta, this way. So this is beta or that is beta. So beta is the outlet. At the outlet, the angle made by the jet with respect to the direction of motion of the vane. Now one more angle, theta at inlet and phi is at outlet. Theta is at inlet again, the angle made by the relative velocity with respect to the direction of motion of vane, also referred to as angle of vane. So in this triangle, apart from horizontal side, which is representing vane velocity, we have got two sides. Already we have seen that this is velocity of the jet. The third side is relative velocity. It is relative velocity of the jet with respect to vane. The angle made by relative velocity with respect to the direction of motion is theta. The theta, if you observe here, it is nothing but angle made by the vane itself, or angle of vane at the inlet. The red line shows that. So that angle is theta. Similarly here, the relative velocity is making an angle of phi. So here the red line makes an angle of phi. That is the angle of vane at the outlet. Now phi and theta are counterparts, one at the inlet, one at the outlet. Now look at the triangle once again more clearly. Horizontal side is represented by vane velocity, whereas the V represents the angle of the Z, and the third one ultimately VR, that is the relative velocity. Here also there is U, there is V, that is angle of jet at the the velocity of the jet at the outlet, and the third side makes relative velocity. Now why it is relative velocity? You know the concept VR, that is velocity, relative velocity is equal to that is velocity of A with respect to B. If you recall, VA bar B is equal to VA minus VB. Now in this case, velocity, relative velocity, velocity of the jet with respect to the vane. So VR2 should be equal to V2 minus U2. Similarly here also VR1 should be equal to V1 minus U1. If you put the equation and try to see, you will realize that VR2 is V2 minus U2, whereas VR1 is V1 minus U1.